Hello everyone, welcome back. Let's process a new temperature sensor that will be ADT75. And to get your hands on the sensor, we need to log in and to pursue the website that will be controleverything.com, and here we have to search on and type in ADT75, and here we are with the temperature sensor. And as you see, it's a temperature sensor with plus minus 1 degree Celsius accuracy and precision, and these are some more prominent features which are onto the screen. Also, you can purchase the sensor right from here. Also, I will be interfacing the temperature sensor ADT75 with a BeagleBone Black and using a C language code, and you get your code. We need to go to resource tab, and here we are with the C code sample. Now you can get your C code sample from this website and you can download as a zip file, and also you can get the code from github.com, and the concerned repository will be Control Everything Community. Now let's have a look over the sensor we need to pursue, and let's make some hardware connections for that. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen, and this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. And this here is our temperature sensor ADT75, and this comes a connecting cable. Now make the connection among the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly to the I2C shield. As we are done with hardware connections, let's have a look over the code. Now let's have a look over the code, and for the interfacing purpose, we need to log in to github.com, and after that we need to search upon the repository that will be Control Everything Community. After getting there, we need our sensor that will be ADT75, and after that this comes the C code. But before that, let's have a look over the instructions part. We need to carefully set up in this part we need to set up the BeagleBone Black as shown, and here this command, this link beaglebone.org. let's open it up. This will help us to set up the beaglebone.org or BeagleBone Black carefully, and as you see, a lot of instructions needed to be taken down. After getting this, we need download or get pull the code onto the BeagleBone Black, and this command will compile and this will run the C program. Now get back to the C code, and as you notice, it's a .c extension file, and the first thing you get your eyes onto the code that we have included some header files and some libraries here. The void main function, we are going to check whether the I2C bus is open or not, and whether the address device we have connected is 0x48 or not. Then we have to read 2 bytes of the data from the register, that will be 0x00, and here we are reading this part, and here comes the conversion of the data which we have seen using some of the formulas from the data sheet of ADT75. At the end, we have to print the output data onto the screen, which comes as temperature in Celsius and Fahrenheit scales. So this is how the code is. Now let's have a look over how it works. Now coming to the working part, which is to check the practicality of the code, we have to copy this entire code as you can see on my screen, and after that we have to go to the terminal for the BeagleBone we have connected, and here we have to create a new file as you can see on my screen, and it's a .c extension, and here we have to paste the entire code, and after that we have to save it. Now for the compilation, as you can see on my screen, this is the command, and let me type the full command for the compilation, and after that we have to compile it, and it's done, it's good. Now for the build of the code, and for the running part, this is the command, and let's see what we got here. We have the temperature in Celsius and Fahrenheit. and it is on to the screen, and when I run again the command, the same temperature with the minimum change is there. But when I press my finger over the sensor and run the command, the change is significant onto the screen, which means we have the Celsius and Fahrenheit changes for the temperature, and when I run again, we have the temperature change again. So this means the sensor is working as per we desire. Now our next motive is to show the applications and some of more benefits regarding this sensor. The ADT75 is a complete temperature monitoring system in 8 LED MSOP and SOIC packages. It contains a band gap temperature sensor and a 12-bit analog to digital converter to monitor and digitize the temperature to a resolution of 0.0625 degrees Celsius. The ADT75 is pin and register compatible with the LM75 and AD7416. The sum of applications which are applicable to this sensor are isolated sensors, environmental control systems, computer thermal monitoring, industrial process control, power system monitors, and a lot more to mention. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.